Hello guys, how are you today? So today I'll be explaining the physics course question document from section 2.10 all the way until section 2.18. Now I forgot if I used to do only the grid or all of the sections, so I'm just gonna do all of the section because it's better practice for everyone. So let us start with the first question, which is question number 26, grid. What is the definition of the SI unit of the electric current? Okay, you need to have this memorized, okay? What is the definition of an electric current or the SI unit of the electric current? So first, in order for us to define the SI unit of an electric current, we will need to define an electric current. An electric current, it is known as what? It is known as a flow of charges. These charges can be positive, these charges can be negative. But as long as it is a flow of charges, then this is known as an electric current. Now, the SI unit of the electric current, which is the ampere, A, okay, it represents what? It represents the flow past a point, that sounded like pasta, past a point of 1 coulomb of charge per second. Now, based on the formulas that we know that the current I is equal to what? It's equal to the quantity of charge over the time. Or in another format, Q is equal to I times T. So if you replaced by the joules, by the units, you're going to have that I, which is in ampere, Q, which is in coulomb, time, which is in second. So 1 ampere is equal to 1 coulomb per 1 second. Very simply, that is it for question number 26, grid. We move on to number 27, grid. They said draw a simple circuit and show the conventional direction of the electric current. So let's draw a simple circuit. For example, you will have the cell. This is the cell over here. The long side is the positive, the short side is the negative. Then you have the connecting wires, and then you will have anything like a light bulb, for example, and then you will connect it over here. Now, the direction of the current is always from positive to negative, but pay attention. They may ask you to draw what? They may ask you to draw the conventional direction of the flow of electrons. Flow of electrons moves from the negative side to the positive side, okay? So keep this in mind. Move on to 28, grid. A hair dryer draws a 9.1 ampere current. How much charge flows through it in 3.5 minutes? Based on the equation we should have memorized, which is Q is equal to I times T. Okay, first of all, Q is what we need to find. Okay, it is equal to what? It's equal to the current, which is 9.1, times the time. What is our time? It's given in minutes, but we will have to change it to seconds. So how do we change it from minute to second? We will multiply it by 60. So 9.1 times 3.5 times 60. You will put it on your calculator, and you're supposed to get 1.9 times 10 to the power of 3 coulombs. Okay, so that is it for section 2.10. Let's move on to the next section, which is section 2.11. It says what? It says 2 coulomb of electrons. So this is the quantity of charge. Leaves the negative terminal of a 1.5 voltage dry cell, V, the voltage, to the positive terminal through a thin wire. How much heat energy is released in the wire, and where does this energy come from? First of all, you have to know the equation. What is the equation? The equation is that the voltage is equal to the energy, W, or the work, over what? Over the quantity of charge. So here the first thing they want us to find is what? How much heat energy. So basically how much energy they want us to find the energy. In order to find the energy, you have to make it the subject. So you will bring Q to the other side. W is equal to V times Q. You have V, which is 1.5, and you have Q, which is 2. Put it on your calculator, solve it mentally, it doesn't matter, you will get the same answer, which is what? 3 joules. Now, where does this heat energy come from? It comes from what? It comes from the electrical potential energy of the dry cell. So if they ask you, where does this energy come from? It comes from the electrical potential energy from the dry cell. So electrical potential energy from dry cell. That's it for question number 29. Move on to question number 30. What does it say in question number 30? What is the energy released by 5 coulomb? This is the quantity Q. Charge passing between 2 points with a potential difference of 3 volts. This is the voltage. Again, they need the energy. What's the equation? V is equal to W over Q. You need W, so W is equal to V times Q. W will be equal to 5 times 3, so it's going to be what? 15 joules. Do not forget the unit. So just like that, we finished what? We finished section 2.11. We move on to section 2.12. What does it say in section 2.12? It says, electric power and energy. For each of the following devices, indicate the type of energy that is being converted to electrical energy. So basically, all they are saying is determine their initial type of energy that is being transformed into electrical energy. A battery, it stores energy in the form of chemical potential energy. Okay, I'm not gonna write energy, just chemical potential. A thermocouple is from heat energy. An electric generator is from what? From mechanical energy. A photoelectric cell, it's from what? It is from light energy. So very simply, these you have to know them based on their names. We move on to number 32 grid. What is the current drawn by 2 kilowatts, which is basically 2000 watts? This is power, by the way. Electric heater connected to 220 volts supply. Remember the equation. You have voltage, you have power. P is equal to I times V. You need to find I, so I is equal to P over V. Just ignore this over here. So what is P? What is the power? The power is 2 times 10 to the power of 3 watts, or 2000 watts, over what? Over 220 volts. It is equal to what? It's equal to 9.09 amperes. So just like that, you found what? You found the current. Then they said, part B, if on average the heater operates 8 hours a day, this is what? This is the time. However, we need to change the time into seconds. So how do you change from hours to seconds? You will multiply by 3,600. Or very simply, you could do it in another way. You could do from hour to minute to second. From hour to minute times 60, minute to second times 60. So multiply them together times 3,600. So let us put it on the calculator. 8 times 3,600, it's going to be 28,800 seconds. We will multiply this by what? We will multiply this by the power. Why? Because they need the total energy consumed. What is the equation? If we have the time and the energy and we need to find the power, we know that the energy is equal to the power times time. We need to find power. Power is equal to energy over time. So it's my bad. We have the power and the time and we need to find the energy. My bad, my mistake. So the power, which is 2000 watts, multiplied by the time in second, which is 28,800 seconds. So in significant figures, it's going to be what? It's going to be 5.76 times 10 to the power of 7. So very simply, that is it for what? That is it for question number 32 from section 2.12. We move on to section 2.13. What does it say in 2.13? So, question number 33. A battery of EMF 4.5 volts is used to operate the bulb. The bulb draws a current of 0.8 amperes. So this is voltage 1. This is the I. When the potential difference across the battery is 4.1 volts, this is what? This is voltage 2. They said calculate the energy of 1 coulomb of charge gains in the battery. What is coming from the battery? It's 4.5 volts. And we have the coulomb, which is what? Which is 1 coulomb. We have Q, which is 1 coulomb, so we can very simply find the energy. W is equal to Q times V. You have Q, which is 1. You have V, which is 4.5. So your answer is going to be what? 4.5. What energy is lost by 1 coulomb in the battery? Pay attention, 1 coulomb. I know I circled up, but it's 1 coulomb. How do we calculate the energy, which is W, knowing that we have the Q, which is 1, and we have the voltage, which is voltage 1 and voltage 2. Very simply, in order to find W, it is equal to what? It's equal to Q times V. But here we'll have to do 2 trials. We'll need to find W1, okay, W2, and we will need to subtract them from each other. W1, it is what? It is 1 coulomb times 4.5 volts. And then W2, it's 1 times 4.1 volts. You're going to get 4.5. And you're going to get 4.1 over here. You're going to subtract them because now you have them in joules. 4.5 minus 4.1. You will get an answer of 0.4 4 joules. We move on to part C. Find the energy that 1 coulomb of charge delivers to the bulb and the wire. So again, the bulb and the wires get 4.1 volts multiplied by the charge, which is 1 coulomb. It's going to give us 4.1 joules. Very simply. So now we move on to part 34, question number 34. A car battery is rated 70 AH. This means what? This means 70 amperes in an hour. So in an hour, 70 amperes is going to pass through the current. They want to know the amount of charge traversing a circuit. So you have what? You have the I, you have the time, and you have what? You need to find, the amount of charge. You will apply the equation Q equals I times T. So in 1 hour, we have 3,600 seconds. That means the amount of charge traversing a circuit branched to the car battery, it's going to be 70 amperes times 3,600. Put it on your calculator, you'll get 252,000 coulombs. Okay, so now we move on to question 35, my bad. Define the electromotive force of a generator. Very simply, what is the electromotive force of a generator? It's another term for the voltage. Another term for the voltage, or not another term, an equation for the voltage, it is W over Q. So, this is the equation you need to know for the electromotive force. If they ask you to define electromotive force, it's V equals W over Q. My bad. However, how are you going to define this in words? It's going to be the energy, so energy supplied by a generator to transfer 1 coulomb of positive charge. Okay? Just like that, we finished section 2.13. We move on to section 2.14. Let me just check how long is it. It's not too, no. Anyways, using the minimum number of elements, set up a circuit to test the conductivity of objects. Using the standard notations, draw a suitable diagram. Okay, so very easily what we will need is first of all a cell. We will need a cell. My tablet fell, my bad. We will need the connecting wires. Do not forget the connecting wires. Then we need to test what? We need to test the conductivity of objects, meaning if they would let a current pass or not. So how would you test that? You'd use an ampere, and you connect the ampere in series. And then over here, you're going to connect what? You're going to connect the object. Okay, so actually it's not this big line. It's still here. This is the object. And then you will just connect the line over here. So this is what it's supposed to look like. You're supposed to have a cell, connecting wires, the ampere to measure the current, and then the object to see if if it conducts electricity or not. Okay, usually metals are better conductors than non-metals. We move on to question number 37. Using the minimum number of elements, set up a complete circuit containing 3 lamps in series. So how would you draw 3 lamps in series? First of all, you're going to have what? You're going to have the battery or the cell. Let's just say it's like this. And then you'll have 1 lamp, 2 lamps, 3 lamps. Okay, so that's part A. Part B, they want 3 lamps in parallel. So you will have a battery. Okay, 1 battery is enough for the 3 lamps because in parallel they will all get the same voltage. So you will have 1 lamp like this, 1 lamp like this, and 1 lamp like this. And this is how you draw 3 lamps in parallel. Now, they said they want 2 lamps in series with combination in parallel with the third one. So again, you're going to have basically the voltages, the cell to give the voltage. And then you're going to draw 2 lamps in series. And then 1 final lamp in parallel to the 2 lamps in series. We move on to 38. What does it say, 38 grid? It says, draw the circuit symbols for each of the following below. Variable resistor looks like this. Okay. Potentiometer. What does a potentiometer look like? It looks like this. So first you draw this. Do not forget to add these. I forgot to add them up here. And then you draw a small arrow. What does this arrow mean? This arrow means you can move it to change the voltage based on how you want it. A heater very simply looks like this. And then you have lines. Okay, and then the final thing is a thermistor. How does a thermistor look like? Thermistor looks like this. Okay, keep these in mind, very important for tomorrow. 39 grid, draw a series circuit consisting of two resistors on a cell. State the characteristics of the resistors. Now, very important, because we are dealing with what we're dealing with a series circuit. That means everything is in series. So you'll have the you'll have the cell over here, then you'll have resistor 1, resistor 2, and then it will go back to the end of the battery. Now, because they are in series, basically they will have what? They will have the same current, so current is the same, whereas voltage is divided among them, so voltage divided among them. However, if we were to put them in parallel, you would have that the current is divided among them, whereas the voltage is the same in each one. Just like that, we finished what? We finished 2.14. We move on to 2.15. So, how is an ammeter connected in series? Very simply, it should... sorry, I gave away the answer, my bad. How is an ammeter connected in a circuit? So, with regard to the ammeter, it has to be in series and the polarity must be respected. What does it mean the polarity is respected? That means one side should be connected positively and the other side should be connected negatively. Very, very important. Okay? Now, for part 41, for 41 grid, how's a voltmeter connected in a circuit? It is connected in parallel and there's no polarity issue. So, there is no polarity. So how is an ammeter connected in a circuit? It's connected in series, but you have to respect its polarity, meaning positive goes with positive, negative goes with negative. Or like you connect them properly, just like how you would connect a battery in the remote. Okay? And then 41 grid, how is a voltmeter connected in a circuit? It is what? It is parallel, connected parallel, but there's no respect for its polarity, meaning you can connect it in any way. So we move on to 2.16, which is about Kirchhoff's law. So first of all, what is Kirchhoff's law? Kirchhoff's law, a very hard name, states that the sum, this is the sigma notation, it means the sum of currents entering is equal to the sum of currents exiting. Okay, keep this in mind. So what does this mean? This means the sum of currents entering this junction over here. Please pay attention to how they are directed. So how they are entering the junction is gonna be equal to how they are exiting the junction. So entering the junction, it's what? It is x plus 3. It's equal to what? It's equal to 2 plus 4. So x plus 3 is equal to 6. Move this to the other side. X is equal to 3 amperes. Very simply, you found the value of x. We move on to 43. So in the circuit below, the voltage across the battery is 24 volts. Resistors 2 and 3 are identical, very important. And the voltage across resistor 1 is 4 times across resistor 2. That means if 2 is x, that means 3 is x. This is, we're talking about their resistance. And also their voltage, because we know that if they are in series, then their current is all the same. So they said 2 and 3 are identical. This is for both voltage and resistance because it is in series. So 2 is x, 3 is x. Whereas resistor 1 is 4 times across resistor 2. We're talking about voltage. That means 1 is 4x. They said using Kirchhoff's voltage rule, determine the voltage across each resistor. What is Kirchhoff's voltage rule? It states that the sum of potential difference in series is equal to potential difference across the whole branch. Or basically, if it is in series, then the voltage is additive or it's distributed among the resistors. So in this case, I prefer you would add them all to get 6x. So the total voltage, 24, is divided among 6x to get what? To get an answer that... to get an answer that x is equal to 4. Is that right? Yes, it is right, but 4 volts. Pay attention. That means resistor 2 and resistor 3 have a voltage of 4 volts, whereas resistor 1 has a voltage of 4 times 4, which is what? Which is 16 volts. That is it for section 2.16. We move on to 2.17. What does it say in 2.17? It says, oh, it's only one question. 44 grid. Calculate the electromotive force of the grouping if the EMF of each cell is 2 volts. So, let's choose one direction, okay? By the way, EMF means voltage. So, If they are in series, then they are additive. If they are in parallel, then they are what? Then they are basically gonna be the same thing. So over here, let's say that this direction is the positive direction. That means this is plus 2 volts. However, this is going in the opposite direction, so it's minus 2 volts, which will lead us to 0 volts. Over here, let's say this is the positive direction, so it's going to be plus 2, plus 2, plus 2, plus 2, which is what? Which is 8 volts. And then finally, for the last one, because they are in parallel, it's basically going to be the same, which is 2 volts. They have no effect on each other. Now, 2.18 is not long. The potential difference across the terminals of a dry cell is measured when a variable current is drawn from the cell. The potential difference is 5.5 volts when the current is 1 ampere, this is the current I, and 5 volts, this is the voltage. When the current is 2 ampere, this is I. Determine the internal resistance of the cell and the potential difference across its terminals when no current is drawn from it. So this is an equation we're barely gonna use, but this is if it comes, if we're dealing with a variable current, okay? What is this equation? This equation is that the voltage is equal to E minus the resistance times I. So in this case, you can find E for both of them, okay, because they have to be equal. E is a constant value for both of them in this case. So they said what? They said that the voltage V, which is 5.5, is equal to E minus R times the current, which is 1, okay? And then the voltage 5.0 is equal to E minus R times the current 2. After mixing it up, or not mixing it, solving it, so 5.5 is equal to E minus R, 5 is equal to E minus 2R. Now make E the subject of the sentence. What am I saying? The subject of the equation, okay? So E will be equal to 5.5 plus R, and here E would be equal to 5 plus 2R. Now equate them, make them, since they're both equal to E, make them equal to each other. So 5.5 plus R is equal to 5 plus 2R. Move this here, move that there. You will get what? You will get that the value of R is equal to 0.5. So you have the value of the resistance, which is 0.5 ohms. However, to find the value of E, of course, we still need to find the value of E. Just substitute it in any of the equations. For example, 5.5 is equal to E minus R times 1, which is 0.5. Move this to the other side. E is equal to 6. And just like that, you found the value of E, which is what? 6 volts. So, again, E is the potential difference across its terminals when no current is drawn from it, which is a constant in both of them. And then the internal resistance, it is R. So we know R is 0.5 and E, it is 6 volts. We move on to question number 46. What are the factors upon which the resistance of a conductor depends? What is the relation between the resistance and the resistivity? And did you say SI unit of resistivity? So resistance depends on what? It depends on the resistivity. It depends on length. And it also depends on what? On the cross-sectional area. So resistance depends on the resistivity, length, and cross-sectional area. From these three important, you can derive the equation that R is equal to the resistivity times the length over the cross-sectional area. This is the relation between resistance and resistivity. Now, deduce the SI unit of resistivity. So basically, resistivity, we need to find its SI unit. How do you find its SI unit? You move this to the other side. So resistance times what? The area over the length, because you will flip it, is equal to resistivity. Area is usually in meters squared, and length is usually in meters. So if you cancel them, we'll be left with the resistance times meter. So area and meter over length equals to the resistivity. So the resistance, it is in ohm, the unit is ohm. So basically it's gonna be ohm times meter. This is the unit of resistivity. We move on to 47. It says define the resistance. How do you define resistance? Very simply, resistance, it is the ratio of the potential difference or the voltage to what? To the current I. In long term, it's the ratio of potential difference across a conductor to the current through it. And this is the resistance. So how I would like to say it is the ratio of the potential difference to the current. you can say the ratio of potential difference across a conductor to the current through it. Okay, that is it for 47. We move on to 48. The voltage across a 50 ohm resistor is 12 volts. What is the current flowing through the resistance? Through the resistor, my bad. We are given what? We are given the voltage and we are given the resistance. In order to find the current, you need to apply the equation V is equal to R times I. So V is equal to what? It's equal to the resistance, which is 50 ohm times I. We need to find I. So V is what? V is 12 volts. To find I, you will move 50 to the other side. I is equal to 12 over 50, which if you put it on my calculator, it's going to be 0.24 amperes. Now finally, we reached question number 49. What does it say? It says the spool of a 20 gauge copper wire at 20 degrees Celsius has a total resistance of this. So we have the resistance over here. Calculate the length of the wire. So we're looking for what? We're looking for the length of the wire, knowing that its cross-sectional area A of the wire is this much, given that the resistivity of copper is this much. So the main equation we have is that resistance is equal to resistivity times length over area. We need to find the length. How do you find the length? You move everything to the other side. If you move everything to the other side, you will get that length is equal to what? To the resistance times the cross-sectional area over the the resistivity. Now all we have to do is substitute. So length is equal to the resistance, which is 0.655, my bad, times the cross-sectional area, which is 0.517 millimeter squared, over what? Over the resistivity 1.72 times 10 to the power of minus 6. But before we proceed, there is a mistake. This is in what? This is in ohm times centimeter. And for us, the basic unit in physics of the length, it is what? It is in meters. So you need to change this one to meters and you will need to change this one to meters. So how do you change them to meters? From millimeter squared to meter squared, very simply, it is very simply by dividing 1,000 squared. Why? Because from millimeter to meter, you divide by 1,000. So from millimeter squared to meter squared, you will divide by 1,000 squared. And then from centimeter to meter, you will what? You will divide by 100. So now, if you change all of the information based on what you have over here, this is gonna be 0.517 divided by 1,000 squared. And this one, you will change it to what? You will divide also by 100. So this unit will be meter squared and this unit will be per meter. Now you put it on your calculator, 0.655 times 0.517 divided, pay attention, divided by 1,000 squared. You put it over what? Over 1.72 times 10 to the power of minus 6. But don't forget, you are dividing by what? You are dividing the whole thing by 100. Now you'll put it on your calculator. And to the most approximate, or like by rounding, you will get the answer to be what? 19.7 what? Meters. Why? Because we changed everything in order for it to be meters. Now everything else, I did it in previous videos, so thank you guys for watching. I hope you enjoyed and have a wonderful day.